So, hi guys. Um, I found another problem in Hakera. So this is a number two. So the second challenge to our Algo challenge here in YouTube. So the problem basically is I given a square matrix, calculate the absolute difference between the sum of its diagonals. So a square matrix, basically speaking, is just a list inside a list. So basically, if you put it in an array, so basically there is an array inside an array. So let me show you. So let's head over to paint. So as you can see, um, a square matrix, basically a square is shaped like this. So it can also be shaped like this, square. So basically, a square matrix is just a list or an array inside an array. So if we have, for example, three arrays here, named 1, 2, 3, 4, 5, 6, 7, 8, and 9. So basically, all these three arrays are compiled or combined into a one array. So it will be um, a one big array. So in that one big array, there are three arrays named 1, 2, 3, 4, 5, 6, and so on. So a square matrix basically is just putting um, a, a list on top on each other. So a diagonal is made when the elements line up like a diagonal on a square. So a diagonal looks like this in a square, like that. So if we put these three arrays on top of each other, you will notice that it will form a square. So this is not technically a square, but you get the point. So these three arrays form a square, and each element is an element of a matrix. So it will be, if we put it simply, it will be built like this. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the task here basically is to add up each diagonal. So you add up all the elements here that matches a diagonal, and also here. So this is the first diagonal. So for example, we have a diagonal 1. Let's declare a variable diagonal 1. So diag 1. So diag 1 is 1 plus 5 plus 9. Diag 2, which is diagonal 2, is 3 plus 5 plus 7. So basically the problem asks us to compute the absolute difference of each um, total diagonals. So if you total this one, you total this. So basically this is diag 2 technically, the total of this. This is diag 2, the total of this. And the difference of each of them is what the problem asks us. So absolute difference. So let's name that absdiff is equal to the absolute difference of diag 1 and diag 2. Oops. Okay, let's see. So it's just a difference. So okay, let's code. So let's head over to our Visual Studio and let's code. So first, before we compute all the total numbers, for example, if we want to compute the total numbers in a list through for loop, or we want to do a while loop, and then we have to compute all the elements on that specific array or specific list. First, we have to instantiate our object. So we have to instantiate first in our paint. So on the illustration that I've showed you, um, we must declare diag 1 and diag 2. So let's head over to Visual Studio. So let us declare diag 1 is equal to 0, for diag 2 is also equal to 0. So um, basically we need to create our own 2-dimensional array. So basically a two-dimensional array is just in the illustration that I've showed you, it's just a list inside a list. So it's two-dimensional in a sense that two we only have a list inside a list. If you want it to be a three-dimensional array, so you have to have a list inside a list inside a list. So it's a two-dimensional array in a sense that it's only on a factor of 2. So there's only just a series of lists inside a list. So it's not recursive anymore. So let's head over to our Visual Studio Code and let's create our own two-dimensional array. So in the example that HackerRank gave us, so as you can see, uh, here's the sample input. So there is this is a two-dimensional array that is already formed as a square matrix. So let's create that like the HackerRank. So okay, so here okay, so here is our two-dimensional array. So we have a series of lists inside a bigger list. So how do we compute our diag 1? So in the paint that I've showed you, so how do we get the values exactly like 159 and 357? And take note, this is a square matrix with a side of 3 units. It is a 3 unit square because each element contains each array or each list contains 3 elements. So if each element contains if each list inside A bigger list contains 4 elements. Of course, it is a square of 4 units of length. So, how do we actually compute 159 and 357 just like this? How do we get that values? So first we have to analyze. um, let's create a bigger square, so let's just delete all of this, and then let's recreate that square. One, two, four, five, six, seven, eight, and 9. So how do I actually get the values 1, 5, 9, and 3, 5, and 7? So in a two-dimensional array, we are thinking of giving this probably like a coordinate value. So if you don't know what a coordinate value means, basically in a graph, for example, a Cartesian coordinate graph, um, a point inside a Cartesian coordinate graph represents a specific point. So this point 1 1, this point is I 0 0, and this point here maybe 0 3, and so on and so forth. So let's try and imagine that in our square matrix. So here, let's imagine this is row, or in the Cartesian coordinate sense, this is x1. So x1 is equal to 0. This row here, so this entire row here, so 1 2 3, this is x1 is equal to 0. Oops. So let's just create that. So this entire row here is equal to 1. X3 is equal to 2. So the reason that these are called 0, 1, and 2, this row here, because if we think in an array, so let's create the array itself. So in an array, we treat the first element, right, as index 0, we treat the second element as index 1, and we treat the third element as index 2. So in an array this big, the first element is this one. So let's just change the color for that one. So the first element is this one, the second element is this one, the third element is this one. So if we try to name this very big array, so let's say this very big array is array A. So array A is equal to this big array. So A 0 is equal to 1 2 3, and so on and so forth. So it is called a two-dimensional array because you can get a specific value. So for example, if we wanted to get a value of 5, or a value of 2, or a value of 3, if we just use just one index, um, we will only get a list. But if we try to, let's say, let we want to get the number 3, So we want to specify that as a 0, and then let's count it in the list. This is a index 0, index 1, and index 2. So to get the number 3, you must then add another index to that. So 2 is equal to 3, right? So basically, in getting each numbers right here, so in getting each numbers, um, we must first specify what row they are in. So in the very topmost part, they are row 0, or x1 is equal to 0. In the second part, so this 4 5 6, this is row 2, and then this 7 8 9, these are row 3. So each row is represented here in the first index. So in if you get the row, then you are able to get the number by getting the second index, which is just naming the index of that specific value. So here, so it's a two-dimensional array because you are specifying two indexes, so two indices in an array, so it's two-dimensional in that way. So how do we actually get um, the values from the table? So let's create that again. So how do we actually get the numbers in this diagonal right here? So notice that in this row, this is row 0. So if we have an array, a big array called letter A, so like previously, then A0, and then we want to get this part right here, which is number 1. To get that, you have to specify A00, right? Because it is the first element of the first array. So A is equal to 1. So how do we get the number 5? So we get the number 5 by, so let us just put an arrow here. So we get the number 5 by, so number 5 belongs to the second row, right? So this is the first row, which is row 0. The second row, which is row 1. So you have to specify A1. Then to get the 5, you have to count it, the value from that list. So A1 1 is equal to 5. Lastly, how do we get the 9? So obviously, uh, it's in the third row, which is row 2, right? So 0, row 0, row 1, row 2. So let's do it, row 2, and it's the third element of that specific list, so it's 2. It's equal to 9. So notice the pattern here. We have A00, A 1 1, A 2 2, to get that specific value, right? So notice that as the row increases, uh, the first row, so this row right here, it's just the same here in the second row. So um, in our code, if we try to think it in our code, when you use for loop, then we can just iterate it in as usual. So if we try to for loop for int I is equal to 0, I is less than array length, so I plus plus, then that specific I, so a, it's just gonna be represented like I. Yeah. So let's head back to our code. So here, okay, then the problem. So let's create a for loop real quick. So the name of our diag one, so you actually just have to add it. So as the for loop, so as the index in the for loop increases, you just have to add it in our diag one. So that's why I put the sign here plus equals. So or, so in that example that I show you, the first index um, is the first row. So the first index represents the row, the second index represents the value that is represented in each of the list. So that's I. Then this is also I. There. So hopefully, so in our paint we have values 1 plus 5 plus 9, which translates to 15, right? So let's head back to our code. So let's console log what really is the value of our so node index js. Oh, okay, so you have a different set of array. So we got this array through the HackerRank. So let's just head back to HackerRank real quick. So in the HackerRank, the primary diagonal is 11, 5, and 12, negative 12. So 11 plus 5 and negative 12 is equal to 4. So in our code, um, yeah, it's correct. It's 4. So now let's head back again to the second diagonal. So the second diagonal, let's just erase this real quick. Create the square matrix again. So now let's try to find out how can we get this value right here. So as you can see, this row is index 0, and this value here 3 that we're trying to get is index 0, 1, 2. So the number 3 here is represented as a 0, 2. So the number 5, we already got it, that one. So it's A on the row 1, element 1, which is 5. And lastly, the number 7 is A of row 2, and it is the first element of that row, so 0. So as you can see, the pattern is quite interesting, because this is 0, 1, 2, but on the second index goes up, right? So here in the first index, it goes um, downwards. On the second element, it goes upwards, right? So what can we infer from this? How can we actually get the index programmatically? So the idea that they came up with is, you have to calculate first the length of your array. So since we have a square matrix here, that is 3 by 3, so this is 3 units, because 1, 2, 3, and this is also 3 units, 1, 2, 3. Basically it's a square. So technically our array is of length 3. So our array length, so let's just erase this one, and then technically our length of our array is 3. So how do we come up with this? So this downwards example, we can create that using for loop, right? Because if we try to iterate it like the first value is I is equal to 0, I is equal to 1, and I is equal to 2. So the first index here is not really the problem, but the problem here is in the second index. So in our for loop, how can we actually get it descending, right? So let's head back to our Visual Studio. So here, as you can see, we can just create I, because in the first diagonal we are just having the same indexes. So in the first index and the second index is just the same, so they are increasing over time. So array 0, 0, array 1, 1, oops, and array 2, 2, so they're increasing every time. But on the second diagonal, how can we create a value that is decreasing and increasing at the same time? So turns out it's just you have just to subtract the length of the array and its its index on the for loop. So if the for loop is for var j is equal to 0, j is less than array dot length j plus plus. The first index is just j, right? So if you have for example a for loop here, or a for loop here, so a, this is just j, right? Because it's increasing. But how do we decrease? So we have to take the length of the array, so length, well, let's just take it as lr, is lar minus the j. So if we try to think about this, we have the length 3 minus j is equal to 0. So 3 minus 0 is technically 3, but 3 is out of bounds in our array because we don't have a element of 3 here. So what we're gonna do is we're going to encapsulate here the j with plus 1. So every time the for loop increases, mm, the j must be increased also by 1. So technically, we have a 0, then 3 minus 0 plus 1, a 1, 3 minus 1 plus 1. So technically, the j is increasing here, plus 1, and also it is subtracted by our array length. So technically, we are decreasing. So let's head back to our code so that you can understand it. So let's create another for loop. It's j. So diag 2 is incrementing r. So the r here is j, and um, it's r dot length minus j plus 1. So let's console dot log this. It's 19. So let's head back to our rank if it's really 19. So here the secondary diagonal is 4, 5, and 12. So 4 plus 9 plus 5 plus 10 is equal to 19. So it's correct, 19. So now we just have to subtract this. So let's var diff, which is the difference of the two, minus diag 2. So diff, it's negative 15. But in the problem, we're asking of the absolute value. So we just have to create an if statement for that. So if diff is less than 0, basically we have to multiply it with negative 1. So we have to create another, actually diff is equal to diff. So that is basically just the code. So if it's less than 0, you have to multiply it by negative 1, else it's just the same. So we don't need an else statement for that. So let's try to run it again. No, it's positive 15. So let's try to run this code. So we don't need to supply this because it's already supplied by HackerRank. So let's try to run this code here. So as I mentioned in the previous video, um, this function here is already auto-generated by HackerRank. So you don't have to worry about it. So as you can see, below it says congratulations, I already solved it. So I just showing the steps on how I solved it. So let's copy paste the code, then return. So I didn't include the console log because we don't really need that. So we just have to return the diff. So let's just run the code, see if there's any problems. Okay, so let's just submit the code. Okay, so that's it. We've solved diagonal difference. So that's it for this video. Thanks.